Okay, in section 6.4 we introduce log functions, and we start with the definition of a logarithm, which you can see here. Y is equal to log base a of x if and only if x is equal to a to the y. So this is related to the exponential functions that we just saw in the last section, and the way that it's defined actually makes it the inverse of the exponential function. We'll see that more as we go. So first we're just going to work with this definition and being able to go between the exponential version and the log version and vice versa. So let's say that we want to convert an exponential expression to log form. Okay, so let's try one of these. We want to convert this to log form. So let's say we have 4 to the third is equal to 64. And we want to write this equation, this expression, in log form instead. So same numbers, just in log form. So this is pure memorization. So the base of the exponential matches the base of the log, and the logarithm is equal to the exponent. So the base is 4, so we've got log base 4, and the logarithm is going to be equal to the exponent. So we've got log base 4 of 64 is equal to the exponent 3. Okay, so base matches base, and log is equal to the exponent. All right, so if we want to convert to exponential form, going the other direction, so convert to exponential form, let's say we have log base 2 of 8 is equal to 3. So when we convert this to exponential, the base is 2, the exponent is 3, so we've got 2 to the third is equal to 8. 2 to the third is equal to 8. Okay, so that's converting back and forth between the two. You need to be super comfortable with this, so there's a bunch in the homework. I would recommend doing as many as you have time for, because the more comfortable you are with that, the better the rest of this section will go. Alright, so this brings us to our first property, and that's log base a of a to the b. We want to know what this equals to. Well, we've got an exponential inside of a logarithm. The bases match. And so, like I said, this definition actually makes them inverses, but we haven't seen how that works yet. So let's just look at an explanation of this and see how it works. So let's say that log base a of a to the b is equal to something. We'll say that it's equal to y, because we don't know what it's equal to yet. And if we take this and we convert it to exponential, the base is a, the exponent is y. So we're going to have a to the y equals what's on the inside, which is a to the b. So a to the y equals a to the b, and if you remember from our exponential section, if you have two exponentials with the same base, then their exponents have to be the same. So this exponent has to be the same as this exponent, and so that means that y is equal to b. So this whole thing is actually equal to b. So what this says is that if you have a log and an exponential with matching bases, they're basically going to cancel out because they're inverses, and you're just going to be left with what's on the inside, which is b. Alright, so let's see how a couple of these work. So let's say we have log base 2 of 8, and what we need is we need it to look like this. We need the bases to match. So we say, okay, we need to rewrite 8 with a base of 2. So I rewrite 8 as 2 to the third, because 2 to the third is the same as 8. Now I can see that the bases match. The logarithm says what's the exponent, and the exponent is 3. Okay, we can also do this with fractions. So let's say we have log base 4 of 1/16. Log base 4 of 1/16. So we say, okay, we need to rewrite this base 4. So this one's a little bit trickier, but we can do it. We want it to have base 4, and we've got to figure out what exponent would make this the same as 1/16. So how do we get from 4 to 1/16? Well, we need to flip it. Okay, flip it means a negative exponent, that's a reciprocal. And then to get from 4 to 16, we have to square it. So we need to flip it and square it. So flipping it gives us a negative, and squaring it gives us a 2. So the exponent would be negative 2. 4 to the negative 2 is the same as 1/16, so we haven't changed anything, we just rewrote it. Now the bases match, and the answer is the exponent, which is negative 2.